all of you in the physics class. In the previous class, already I have explained the simple pendulum. Okay, in the previous class, already I have explained the simple pendulum, and today I am going to start some more things that was left in the simple pendulum, as well as I am also going to start the one more topic was left in that particular chapter, experimentation and measurement, and that is the last unit of that chapter, graph. Graph is also important for all of you in the this class also, as well as also in mathematics, as well as in physics, as well as also in the as well as also in the higher class also, for the practical point of view, as well as also it will be also quite helpful once you are going to face the competitive exam also. Okay, so simple pendulum, in the previous class already I have explained simple pendulum. What I have explained the simple pendulum? Simple pendulum is a device. Simple pendulum, if we take a bob, and if any bob is attached to a weightless and inextensible thread. Okay, if a bob is attached to a weightless and inextensible thread and is capable to move to and fro from its mean position, this side as well as this side also. That means simple pendulum is able to move to and fro from its mean position. So it is called the simple pendulum. Okay. So simple pendulum is a device in which we have to take a bob, and that bob is attached to a weightless and inextensible thread. Okay, already this thing I have explained in the previous class, as well as also explain the formula, by which formula you can find out the time period. Okay, the time period for the simple pendulum, T equal to 2 pi under root L by G. This formula I have explained, where L is the length of the thread. Okay, length of the thread, and G is the acceleration due to gravity. By this formula we can find out the time period of any object. Now if we want to define second pendulum, one more thing that was left in the previous class, because time was not too much, that's why I have not explained, but today I am going to explain second pendulum. How you can define second pendulum. So second pendulum is a if any pendulum whose time period is 2 seconds. Okay, any pendulum whose time period is 2 seconds is called second pendulum. Okay, from the name it seems to be clear. Second means first, after first second will come. Okay, then that means on this basis we can define a pendulum whose time period is 2 seconds is called second pendulum. Okay, and by the use of second pendulum we can also find the length of the thread. That means if any pendulum whose time period is 2 seconds, what will be the length of that particular simple pendulum? So on the basis of this formula we can find out T equal to, formula is T equal to 2 pi under root L by G. Okay, and according to the definition of second pendulum, any pendulum whose time period is 2 seconds is called second pendulum. Okay, any pendulum whose time period is 2 seconds is called second pendulum. Okay, so that means from the basis of the formula we can from the basis of this definition we can write T equal to 2 seconds. For what? Because already I have defined second pendulum is that pendulum whose time period will be 2 seconds. Okay, Okay, that means in place of capital T, we can put over here 2. 2 equal to 2 pi under root L by G. This 2 will be cancelled. So 1 equal to pi under root L by G. So on this basis, we can also calculate over here 1 equals to pi square L by G. So L equals to G upon pi square. Put over here 9.8 and here also 9.856. So what you will get? Here I am going to write. So you will get L equal to 99.9 centimeter, or we can write 1 meter about. Okay, that means, see here, second pendulum is that pendulum whose time period is 2 seconds. Any pendulum whose time period is 2 seconds is called second pendulum. Okay, so on the basis of the definition, t equal to 2 seconds. So formula already we are knowing, t equal to 2 pi under root L by G. Okay, so here I have put it the value of capital T equal to 2 seconds. So 2 equal to 2 pi under root L by G, or we can also write 1 equal to pi under root L by G. Here also calculated 1 equal to pi square under root L, because we are squaring both sides. Okay, here we have got 1 equals to pi under root L by G. So square both sides. Once we are going to square both sides, we will get what? 1 equals to pi square L by G. So L equals to what will get? G upon pi square. So what will get? That means once you are going to calculate the length of the second pendulum, so what will get? L equals to 99.9 centimeter or 1 meter about. That means if we want to calculate the length of the second pendulum, so on the basis of the formula that we have already explained in the previous class, t equal to 2 pi under root L by G, easily we can calculate what will be the length of the second pendulum. Okay, by this method you can calculate the length of the second pendulum. Now, how we can draw the graph? Okay, because most probably once you are going for the lab, so sometime also you have to draw the graph in between the L and T square, or how you can calculate the acceleration due to gravity by using the length and time. Okay, most probably this thing you will get in the lab in class 9th also, as well as in the higher class, that means in class 11th also. This practical you will also get. Okay, so if from the very beginning, if you are knowing how we can draw, if from the very beginning all of you are knowing how we have to draw the graph, easily you can draw the graph also. Okay, now so right now I am going to explain how you can draw the graph in between L and T square, as well as root L versus T. Okay, so already we are knowing T equals to 2 pi under root L by G. This formula already we are knowing. Okay, so we can also write T square equals to 4 pi square L by G. Okay, now again we can write T square proportional to L. Okay, T square proportional to L. On this basis, we can draw the graph. That means this thing can be taken on the x-axis and this thing can be taken on the y-axis. That means if we want to draw the graph in between L and T square, so easily we can draw it. Okay, how we can take? Just see it. Here L and here T square. Okay, now easily we can draw the graph like that graph you will get. Okay, now that means next topic that I am going to explain, because until and unless you are not going to, until and unless you are not knowing what is the definition of the graph and what is the role of the graph and how we can draw the graph, how we can choose the axis, then it will be useless to explain this one. Okay, so better first of all you must be knowing how we can define graph as well as how we can draw the graph. Okay, so the last topic of this chapter, measurement and experimentation, last chapter I'm going to explain, because in the previous class it was not enough time to explain because next class was also going to start. So that on that day I have not explained that topic graph, but today is the last topic of this chapter that I'm going to explain. Okay, after that the second chapter I will start. In the next coming turn I will start the second chapter, but right now try to understand how we can define the graph. Graph. Okay, how we can define graph? A pictorial representation. Okay, a pictorial representation between two variables. Two variables means, that means two variable can be physical variable, it can be, that means it may be in the terms of velocity and time, it may be in the terms of force and acceleration, it may be in the terms of this time and velocity. That means in any manner there must be two physical variables must be there. Okay, so again I'm going to define how we can define the graph. A pictorial representation of the two physical variables. Okay, a pictorial representation of two physical variable recorded by an experimenter. Okay, that means if any person is going to do the experiment and two physical variable all the time it is going to take the readings, try to understand the concept of that. If any experimenter is going to do the experiment and it is going to take the different readings of the two physical variable, and on the basis of these two physical variable if we are going to draw a pictorial representation on the graph paper, okay, or a pictorial representation at the piece of paper, so that is called the graph. Okay, again try to understand this one. If uh, if any experimenter is going to do the experiment and two physical variable reading all the time he is taking, okay, and on the basis of these two physical variable if we are trying to draw on two different axes, then whatever the picture of that two physical variable we will get, okay, on the different points of the different coordinate system, so that is called the graph. Okay, or we can also define a pictorial representation, of two physical variable. Again try to understand the concept of the definition, okay, and how we can define the graph. A pictorial representation of two physical variable recorded by an experimenter is called graph. Okay, a pictorial representation of two physical variable recorded by an experimenter is called graph. Now, how we can draw the graph and how we can choose the axis? So, we can take two axes, x axis as well as the y axis. If suppose from the origin, basically in the mathematics, in the coordinate system we are taking the origin that means 0 0. Basically in the coordinate system we are taking origin 0 0. So if from the origin system we are going horizontally. Horizontally. So it is called x-axis. Okay, if basically in the mathematics we are taking the coordinate system, or if we are going to take any origin, so from origin, if in the horizontal mode, okay, if in the horizontal mode, if we are moving from left to right, then that will be known as x-axis. That is known as x-axis. And if we are moving from top to bottom, bottom to top, sorry, bottom to top, okay, bottom to top, so that is called y-axis. Okay, from left to right we have to suppose it the x-axis, and from bottom to top we have to take as y-axis. Okay, that is called the horizontal axis. It is also known as horizontal part or horizontal axis, and this is called the vertical axis. So before starting the graph, so these two things, okay, how we have to choose the axis. So this will be x-axis and this will be y-axis. Now the next thing is, suppose two physical variable you have got, and you have to draw the graph in between the two physical variables. Just I am going to take the example that all of you are knowing the potential difference is directly proportional to current. Okay, all of you are knowing this one, the potential difference is directly proportional to current. Okay, so how we can draw the graph? Now after that, two more things you must be know, how we have to uh, choose it, which axis you have to take which physical variable. Okay, so suppose we are knowing formula V potential difference directly proportional to current. Okay, potential difference is directly proportional to current. So there are two types of variable. Since already I have explained in the very beginning of the definition of the this graph, if we are going to take two physical variable, okay, that means by on the basis of the two physical variable you have to draw the pictorial representation. Try to understand the graph very properly, because the thing is that if graph you are not knowing, so it will be not good for you for in the during the practical time, as well as also in the higher classes once you are going to draw the graph. So if from the very beginning, if you are knowing this one, how you have to draw the graph and how you have to take the variables, which axis you have to take which variable, then it will be quite helpful in the higher class also. Okay, so see, V proportional to I, there are two types of variable in the graph. Two types of variable. One is independent variable, and second one dependent variable. Two types of variable you have to take. Okay, dependent variable and independent variable. Dependent variable is that variable that will be here. That is I'm going to explain from here. V proportional to I. That means once there will be change in current, potential difference will be also change. In the previous class also, I have also explained this thing. Try to understand this concept. If current is going to change, then potential difference will be also changed. No change in the current, no change in the potential difference. Don't say like that कि potential difference, don't say like that कि potential difference depends upon the current. Okay, try to understand this concept. Don't say potential difference potential difference will change according to the current will change according to the potential difference. Okay, once there will be change in current, potential difference will be also change. Okay, that means potential difference depends upon the current, not the current depends upon the potential difference. Don't say opposite in manner. Okay, that means current, once the current will change, potential difference also change. That means this one is the independent. Current is independent. Okay, current is independent while this one is dependent one. Okay, current is independent one and potential difference will be dependent one. That means since the potential difference depends upon current, try to understand this one, because maybe in the once you have to draw the graph, nothing will be given to you, and if you have to find how you can choose the variable physical, which variable on which axis, then for that particular point it will be quite helpful for you. V proportional to I, the right hand side that is proportional to part, that will be independent variable. That means I will be, I is independent variable and V is dependent variable, already written. Okay, so independent variable, okay, independent variable all the time taken onto the x axis. Independent variable all the time take onto the x axis, while dependent variable all the time take x axis. By this way you have to draw the graph. Dependent variable all the time take onto the y axis. Now if any formula in the higher class as well as in this class it is given to you, and if you have to find out how you have to calculate, how you have to find the dependent variable as well as the independent variable, then by this way you can choose the which variable on which axis you have to take. So again I'm telling this thing. Firstly write the formula and see which physical variable is depending upon which physical variable. Okay, the independent one take onto the x axis. Okay, independent one take onto the x axis and dependent one take onto the y axis. By this way you can find out which physical variable you have to take on which axis. Now starting with the taking the example of the v proportional to I, since already I have explained this independent variable you have to take onto the x axis as well as dependent variable you have to take onto the y axis. Now already I have explained v proportional to I. So I am just going to take some data. On the basis of that data I am going to explain how you have to draw the graph. Suppose I have just taken V and I. Suppose some readings I am going to take just as an example is 0.0. Okay, 0.40 and some from my own side I have taken, and on that basis suppose you have to draw the graph. Okay, so already explained that since v proportional to I, so this one you have to take on x-axis and this one take on y-axis. Why it will be take on x-axis and why it will be take on y-axis? Because I or v always depends upon I. That means I is independent one and v is dependent one. So since y is dependent one and this I is independent one, so draw the graph like that. Okay, this is the I and this one V. This one I and this one V you have taken. Now see it here. Here taking from 0.10. Here take it. 0.10 starting from 0.10. Then here 0.20. Here 0.30. Here 0.40. Here 0.50, like that. And here take it 0.20, 0.30, 0.40, 0.50. Now how you have to mark the point? In the graph paper, basically the graph paper you are getting 10 division will be there. Okay, you can see it also here. See, there are 10 division on the graph paper. 10 division on the graph paper, just see it. 1, 2, 3, 4, 5, 6. See it from the graph paper. Graph paper already you have used in the previous classes also, 8th class also you have used, but see it also here. So 1, 2, 3, 4, 5. Okay. See in the graph. Here I am going to draw between 0.10 to 0.20. There will be 10 division, a small division. Here 1, 2, 3, 5, 6, 7, 8, 9, 10. Like that it is division, it is given. Okay, now how you have to choose the scale? Next part is very important part for you, how you have to choose the scale. This thing you have taken. First of all, you have to take which physical variable is dependent one and which physical variable is independent one. This thing you have already explained, since we always depends upon I, that means I will be current will be independent one while V will be dependent one. By this way you can find out. Now the dependent one you have to take on y-axis and independent one you have to take on to the x-axis. Already I have done this one. Now second thing you must be knowing, if suppose you have to draw the graph, then how you will choose the scale. Okay, second thing you have to find out how you will choose the scale. Try to understand, don't avoid this thing because this one is very important for all of you. You must be knowing how you find how you will choose the scaling, how you will draw the graph, because in the higher class most of the students are going to confuse how to choose the scale, how the scale we have to write. I have seen, I have taken the attention those students, those who have not taken the proper care in the very beginning of the class, in the lower class, they are facing a lot of problem once they are going in the higher class, and once they are getting the graph, then they are unable to find which which physical variable we have to take on which axis. Most of the times our students are going to confuse. Okay, so if in the very beginning, if you are quite serious, and if right now you are going to see 100%, there will be not a single person, there will be a chance of confusion or okay, axis already explained. Now second thing, see, there are 10 division. So if you want to choose, so suppose you are going to choose x axis, then x axis equal to number of square, we are going to write x axis equals to number of square available, that is upon number of division. Okay, by this formula we can find out number of division or number of points. You can write, better write number of points. Number of square upon number of points. Okay, so see, from from 0.10 to 0.20 there are 10 division. Okay, again listen, from in between 0.10 to 0.20 there are 10 divisions. So if there are 10 division, so here you have to write 10. Okay, because already I have written here number of squares available. So number of squares available is 10. Already see it here, from here also. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10. So 10 divisions, 10 square is available here. Or also you can take from here to here. Okay, I am going to take one division. You can also take from here to here. See 10, 10, 10, 10, 10. Okay, that means 10, 20, 30, 40, 50 divisions. So you can also take like that 50. Okay, and from here to here also 50 divisions. So 50 upon 50, that will take 1. That means the value of the one very small square, it will be 1 ampere. Okay, the value of the one very small square, it will be 1 ampere. That means x axis, one small square equal to 1 ampere. By this way you have to, by this way you can also choose onto the this. If you want to choose, already I have written the formula. Formula is this one, number of squares upon number of points. So number of square available, just see it how many number of squares you have taken. Or you can also take in between the 2 points, both the concept you can apply. Whatever the things that, suppose you have started from here 0.10 to 0.50 or 0.60. Okay, to total count the total number of squares from 0.10 to 0.50, how many squares are there, upon number of points. That means number of points, how many points you have taken, 50 points you have taken, 0.1 to 0.50. Okay, that means since on the x axis 50 points you have taken, as well as the number of square available on the x axis is also 50 you have taken. So 50 upon 50, that will be 1. That means the value of the one very small square division value, it will be 1 ampere. Okay, 1 ampere. Now suppose, and same formula you have to also apply for the, same formula you have to also apply for the one y-axis also. Number of square available onto the y-axis upon number of points. Okay. Now see, here, see from the graph, here it is given 0.1 at 0.10. Okay, at 0.10, not here. 0.40, 0.50. Now, at 0.10, 0.12. At 0.10, there will be also 10 division. 10, 20, 30, 40. Here, see here. At x-axis, it is I. At x-axis 0.10. See it very properly. At x-axis 0.10. Okay. At x-axis 0.10 and at y-axis 0.12. So here 1, 2, 3, 4, 5. A number of divisions will be there. So at here it will be here. Some above from 0.10. Okay. Now second thing, 0.20 to 0.24. So here 0.20 and here above 0.24, again 10 division will be there. So here you can take some more height. Okay, again like that you can take some more height at 0.30. Again like that, and you will get a straight line. By this way you can draw the graph. Okay, by this way you can draw the graph. If you want to see on the graph paper, I can also show you onto the graph paper. Just see it here. Some more things I am going to explain. 0.10, 0.20, 0.30, 0.40, 0.50, 0.10, 0.20, 0.40, like that. See here, here 0.10, 0.20. See it properly, like that I have taken. Okay, then 0.10, see it properly. At 0.10, here at 0.10, just see it is I and it is V, like that only. At 0.10, see 0.10, and since I have already taken one division, one very small square division, it is of 1 ampere. And in the same way also, because same division also here, so one very small square division on the y-axis, it will be also 1 volt. So here 0.10, here since every division is consist of 0, so it will come here. Since already 0.20 is here, just see it 0.20, then see 10 division, 20 division, see 20, since it is 0.24, so mark it here, see it. Okay, then here see 0.30, then see from the graph 0.30, 0.36, so draw it here. 0.36 will be here, sorry, 6 will be here. See properly, I am going to explain here, 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 then see 0.40, 0.40 here taken, then how much? 0.48, see it 0.4, then see it, it will become here, here. So join it. By this way, see it, by this way you can draw it. That means you have to choose the x-axis also as well as y-axis also. Then after that you have to draw the graph, see it properly. If anything is not clear in that one, this one it will be clear. Okay, now draw here also. By this way you have to take onto the, this is here. Sometime the students are also writing that coordinate system also. Here writing 0 point x-axis 0.10 comma 0.12. Here writing 0.2 sorry 0.20 comma 0.24. See, this is x-axis and this one y-axis. This one x-axis. Sometimes the students are also writing like that. You can also write like that, but don't try to write like that, because in the higher class it is not going to permit. So draw, after drawing like that, after drawing the graph like that, if you have to find out how you can find the slope. Okay, but before that you must be also knowing कि if you are going to draw the graph, first of all take the x-axis, take the y-axis, write over here कि on which axis which physical variable you have taken. These are the very important thing that you must be knowing. If you are choosing the x-axis and y-axis, you have to these things is very important things that students must be knowing. If you have drawn the graph, so draw the graph in that way by which on the x-axis write which physical variable you have taken, on the y-axis which physical variable you have taken, mention it. First thing, very important thing. Second thing, write the scaling that you have chosen onto the x-axis as well as onto the y-axis. That means on the x-axis how much scaling you are going to take, maybe sometime it can be different. So whatever the scaling you are going to take onto the x-axis as well as onto the y-axis, both the time scaling you have to write it. Third thing, you have to see it, you have, it is mentioned in the question paper or not, draw the graph from the origin, or suppose if it is not mentioned start from the origin. If you are not going to start from the origin, you can also start from here 0.10 or 0.20 or 0.30, whatever according to the need of the question, according to the need of the physical variable. Okay, don't, it is not compulsory. Again I am telling this thing, it is not compulsory that you have to start from origin. According to the question also you can start the taking the readings. Now fourth thing, whenever if you are going to draw the graph, the pencil, your pencil must be sharp one. Okay, your pencil must be sharp one, it should not be thicker. If once it will be thicker, maybe because the squares are very, in the graph paper the squares is very small one, and maybe if your pencil will be thicker, so it will be one point maybe overlap to second point. So if once you will use the sharp pencil, so it will be, the graph you will get perfect one. Fifth thing fifth thing, that must, it must be, sometimes the students are mentioning over there that on x-axis what is the reading, just like I have mentioned here 0.10, 0.12, 0.20, 0.20, 0.24, like that the students are mentioning. And once the points we are getting, so you can mention like that, but don't mention otherwise if suppose the points are too much closer to each other, then it will be not able to draw the proper graph. Then sixth thing, if you have drawn the graph and suppose all the points are not getting in the same line, don't take tension. Okay, there must be best fit line. Best fit line means if suppose 5 readings you have taken, 6 readings you have taken, Okay, and if suppose 5 or 6 readings you have taken, and maybe the all the lines will be, all the points will be not in a same line. Okay, maybe all the points that you will get, it will be not in the same line. Don't take tension. Best fit line means minimum 3 points should be in a same line you should get. Okay, these things you must be knowing once you are going to draw the graph. And graph is very important. So uh, if once you are in the very beginning, if the graph part is clear, it will be quite fruitful for you to draw the graph in the higher class also. Now come to the key, how we can draw the graph on the basis of some more formula I'm going to take. V equal to velocity equal to displacement upon time. Velocity equal to displacement upon time. This is the formula by which we can find out the velocity. So distance equal to displacement equals to what you can write? Velocity into time. Okay. Velocity equal to displacement equal to velocity into time. Velocity equal to displacement upon time. Now distance displacement equals to velocity into time. Now we can also write d proportional to t. Okay, already I have explained ki how you can, already I have explained ki how you can find the, how we can check the which one is the independent variable and which one is the independent variable, which one is the dependent and which one is the independent variable. So see, in this one, tell me in which one will be independent variable and which one will be independent variable. I think this will be the independent variable. And this will be dependent variable. Because as well as the time will change, displacement will be also change. Once a car is in motion, once a car will be in motion, and as well as the time will pass, the displacement will be also change. Or if any object is in motion, if once we have applied the force and once the body timing is changing, then displacement will also change. That means time we have to take on this axis and displacement also we have to take on this axis. Got it? By this way we will draw the graph. This is called the increasing. This is called the increasing. Increasing means as well as time will increase, displacement will also increase. Time will increase, displacement will also increase. Time will, that means once we are going to change the time, once we are going to increase the time, displacement will also increase. And this one is opposite in graph. That means it is inversely proportional. Okay, just like I am taking the example, according to the Boyle's law, P is V is inversely proportional to P, or P is inversely proportional to V, like that. Okay, according to the according to the Boyle's law, the volume is inversely proportional to pressure. Okay, so that means graph will get like that. This will be volume, that will be pressure, like that. Okay, that means once the graph you have going to draw, sometime it will increase also, sometime there will be decrease also. Okay, so on that basis we can check which one is increasing and which one is decreasing. This is increasing one, this is decreasing one, this is decreasing one, increasing part, decreasing. This is getting like that. Okay, that means on the basis of the two physical variable, we can decide which one is increasing one and which one is decreasing one. Now, all the parts of the graph and all the parts, all the units of this chapter has been over. Okay, today it was the last unit, fifth unit of the experimentation and measurement. Already I have completed. Now in the next coming class, I will explain the second chapter. Now notes and some questions answer, as well as the homework part, uh, after 1 or 2 days you can see on the school website. Okay, so try to just try to just revise each and every. Thank you to all of you.